Hey there, how you doing? Are you stressed and don't know what to do? Tired of reading your boring textbook? And also, are you tired of boring lecturers at your school? Here is your one-stop destination to sort out all your problems. Smart Book Neet series brings some amazing and quality content for all the Neet aspirants out there. This YouTube channel is very beneficial for all the biology, science students out there. Now, learning becomes easier. Stay at your comfort zone and listen to our daily interactive online sessions for absolutely free of cost. So, why should you choose SmartBook as your option? We provide quality video lectures through our modern qualified teachers with some amazing presentations. We've doubt clearing sessions, quiz sessions, daily practice problem sessions, etc. We also provide PDF for every lecture so that it will be useful for your future reference. So, why late? Subscribe to Smart Book Neet.
Hey guys, welcome to our amazing YouTube channel, Battery platform, that is Smart Book, and we have started this amazing Neet series for all the Neet aspirants out there. For that, make sure to subscribe and tap the bell icon to get instant updates of our channel. Until now, we have done biology chapter 1, that is lecture 1 and 2, and we have done physics, that is units and dimensions, lecture 1. Now we are in chemistry, that is lecture 1, based on the chapter some basic concepts in chemistry. And don't worry, and we are there for you, and it's also beneficial for JEE advanced and all the JEE and Neet aspirants out there. So for that, make sure to subscribe and tap the bell icon. So let's get started. So we have created an amazing Telegram group for all the Neet aspirants out there. So we'll be leaving our Telegram group link in the description given below. So the Telegram app looks like this. So make sure go ahead and download Telegram app and join through the link given in the description given below, so that you can get instant updates of our YouTube channel, and we'll be posting some quiz sessions and PDFs over there, so that you can have a brief knowledge about it. Okay, and now our first chapter is some basic concepts in chemistry. So this chapter is gonna be of total of 5 lectures. For that, we are in the first lecture right now, and we'll be uploading further 4 lectures again in upcoming weeks. For that, make sure subscribe and tap the bell icon. Okay, and today is our chapter, some basic concepts of chemistry. So what is chemistry? We need to know what is chemistry. Study of matter and its properties. What is matter? Matter is anything that occupies space and has mass. Anything that has mass and occupies space. For example, if you have a mobile phone, for example, this is a pencil I am having. So this has some mass and it occupies some space. If I keep over there, it occupies some little amount of space. So this is called a matter. Anything that has mass and occupies space is called matter. And study of matter and their properties. What kind of property does it has? It has smooth texture over the end. It has very tough nature along the body, and it has a very sharp tip. So these are some of the characteristics and properties. It may be of physical or chemical properties, and this is called as chemistry. And there's also another definition of chemistry that we'll be learning in our upcoming slides. Nature of matter. Anything that has mass and occupies space is called matter. That's what we came to know right now. Everything around us, for example, book, pen, pencil, wood, water, air, all living beings are composed of matter. What is matter? Anything which has mass and occupies space is known as matter, and it has 3 following features: touch, smell, taste. These are the 3 important features of matter, but these 3 are not known as matter. Anything that has any one of these features is considered as matter. So anything that is able to be touched. So for example, this is a pencil and we can touch this, or if we take a food, for example, we can smell it or taste it. So that is called as matter. Anything, these 3 features, these are the 3 features of any matter. Okay, that any matter possesses these 3 features. What are they? touch, smell and taste are the three important features of any matter. Some basic concepts of chemistry we have. I've told you that there is another definition of chemistry, that is chemistry is the science of molecules. What is the science of molecules? Science of molecules, the chemical interactions, collisions between the molecules and the transformation. So if they collide or they mix up together, they transform, they create a new compound. For example, element O plus another element O forms O2 molecule. It's a gas molecule. Molecule is also known as organic compound. The transformation, this is known as chemistry. Chemistry is nothing but the science of molecules and the transformations. For example, H2O, O2, N2, CO2, etc. Okay, it is a science not so much of the 100 elements but of the infinite in variety of molecules that may be built from them. So basically chemistry is not about the elements, but the elements together form several kind of molecules, and these molecules, they are transform and they collide and become some another form, and those study of matter and its properties, that the molecules that are built from the elements is known as chemistry. So we have elements and we have the sub and the group of elements form molecule, and these molecules and their transformations is generally known as chemistry. Did you understand? For example, if you see any TV show or anything, if you see two lovers or boyfriend or girlfriend, we can see that chemistry is working out very well. Why don't we use physics and mathematics or any kind of stuff? Because it is just some relationship like that. You can have a brief understanding about it, right? Okay. Importance of chemistry. What is the importance of chemistry? It plays a vital role in science and is often intertwined with other branches of science. What are the other branches of science? For example, physiology, anatomy. There are several kind of stuff. In biology also we use chemistry, because in the chemical storing process or in any kind of herbarium or any kind of latest stuff, we use chemistry because we use those chemicals. That's why chemistry also plays a very important role in science, and it's also intertwined with the other branches of science. Chemistry provides methods for the isolation of life-saving drugs from natural resources and makes possible synthesis of such drugs. What does chemistry do? It provides pharmaceutical drugs. What are these drugs? Medicines. For medicinal purposes, chemistry plays a vital role. Due to, for example, we have coronavirus, COVID-19. This is a major pandemic in our country, right? In India, it's a major pandemic. So how are we going to make that vaccine? Of course, statistical data is also very important in finding the vaccine, but of course chemistry also involves a major role, because chemistry prepares a vaccine. With the help of chemistry, we can prepare some of the vaccines with some of the available resources, right? And with that resources, we're gonna make some chemicals and prepare them, and that is known as vaccine, and it involves the chemistry, right? That's what you have to remember. Chemistry has helped in dealing with some of the pressing aspects of environmental degradation with a fair degree of success. Of course, chemistry creates a problem in the environment, but it also creates a solution for it. For example, chemistry, due to the pollution. Pollution is due to several chemical pollutants out released from the factories and all. It is due to the chemistry, but there is also solution to that. What is that? Synthesis of such pollutants before releasing into the water or into the air. We do synthesis. It involves chemistry. Otherwise, planting of trees. There are some essential precautions that we need to take while releasing those harmful pollutants. Chemistry plays a vital role in science, and it also intertwined with the other branches of science, and as well as it forms a very medical, it plays a very vital medical role in our country, and as well as it plays a vital role in environmental degradation and with a fair degree of success. Chemistry creates the problem and gives a solution for it. Okay, did you get the point? And properties of particles of matter. The particles of matter attract each other. Why do they attract each other? Due to rigid volume and rigid shape. Due to the matter has some rigid shape and rigid volume. This causes matter to attract. Okay, the particles of matter are the constant state of motion. What is this constant state of motion? It is nothing but thermal motion. So particles of matter are constantly under thermal motion. What is thermal motion? It's a form of kinetic energy. We'll be learning about thermal motion in our upcoming slides. Thermal motion is of three types: vibrational, rotational, translational. For solids, liquids and gases, there are three different kinds of thermal motions, and we'll be discussing about it right now. So thermal motion is of three types. First one is vibrational. What is vibrational? To and fro motion across main position. In physics, if you learn about to and fro motion, that is oscillatory motion in simple pendulum clock, we can see to and fro motion. That is what here the case is. To and fro motion of particles across the main position. There is no change in volume and there is no change in shape. Solids, the particle shows vibrational motion. Which form of matter comes under vibrational motion? Solids. That is the answer. They don't have they have specific shape and they have specific volume, and they don't change. They always fixed. They are permanent. In solids, the attractive forces overcome the thermal motion. Due to the attractive forces between them, it overcomes the thermal motion. I forgot to tell you, thermal motion is of kinetic energy. What does kinetic energy do? It tries to move away the particles. It tries to separate them. Thermal motion tries to separate the particles of matter. Whereas what does attractive forces do? They try to attract to each other. In solids, this kind of, due to they are tightly packed, right? The particles of matter are tightly packed in solids. That's why their attractive forces are very more, and this attractive forces overcome the thermal motion. Here, for example, if we take a solid, this is how the molecules will be, right? They are tightly packed and they are not compressible. They cannot be compressible. That's why there is huge amount of attractive forces, because there are very less spaces, because they are very tightly packed. Due to the tightness, there are very less spaces among the molecules. That's why attractive forces are more and thermal motion is less. Thermal motion. What is thermal motion? Thermal motion is a kind of kinetic energy. What does kinetic energy do? It tries to separate the particles of matter. Due to, if attractive forces increases, and then the thermal motion gets decreases. What is thermal motion? Kinetic energy. I'm repeating this again and again because it makes you stick in your mind and it gets into your subconscious mind. Okay, yeah. Attractive forces and thermal motion are indirectly proportional. Okay, that you have to remember from this slide. Okay, and let's come to rotational. Rotational includes liquids. Liquids kind of matter. Shape will change. In liquids, the shape changes according to the shape of the container. So if we take a flat vessel, the liquids get will be like this. And if we take a jar, it will get adjusted to the shape of the container. Okay, and here the substance flows. Gas and liquids are known as fluids, and it's a very important term you have to remember. Not only liquids forms fluids, but also gases are also known as fluids. So why do they call fluids? Fluids are nothing but which have the ability to flow. Fluids are nothing but ability to flow. Substances which have ability to flow are known as fluids. You might have learnt about these fluids in your 8th or 9th grade, where you have learnt about fluids and several types of fluids. Fluids are nothing but the substances which has the ability to flow. Due to their ability to flow, liquids and gases also flow in the air. Moving air is called wind. That's why they are known as fluids. Volume remains constant, they don't get changed. They have fixed volume. Liquids show vibrational and rotational motion. So here liquids not only possess this rotational motion but also possess the vibrational motion. This is the key point you have to remember. Don't worry, we'll be providing this entire session PDF in the description box even below, so that it can be used for your future reference. Okay, so for that, make sure to subscribe and tap the bell icon to get instant updates of our channel. And they have fixed volume but no specific shape. Why don't they have specific shape? Because they get adjusted to the shape of the container. For example, the vessel is like this, and if you pour any liquid or any kind of water, so it gets adjusted to the shape of the container. For example, if you take a cup like this, it gets like this. If you take a very vast surface area kind of vessel, it gets adjusted. Okay, it gets adjusted to the shape of the container. They take the shape of the container. This is what you have to remember. And translational, here gases plays a vital role in translational motion. When thermal motion completely overcome attractive forces, then particles move independent of each other. So I've told you, in solids the molecules are tightly packed. This is in the form of solids. In liquids, they are somewhat loosely packed. In gases, they are very loosely packed. They're very loosely packed. Due to their nature, they are highly compressible. Due to the highly compressible nature, they overcome the attractive forces and thermal motion increases. This is reverse to vibrational motion. In vibrational motion, attractive forces are more and thermal motion is less. Whereas in gases, the thermal motion is more and attractive forces are less in gases. Okay, that's what you have to remember. The shape and volume is not fixed. In gases, they don't have any specific shape and volume. In liquids, volume is constant and shape is irregular. Gas take the shape and volume of the container in which it's kept. You have to remember this. Okay. And nature of matter, solid and liquid, when are in a condensed state, they are non-compressible. Okay, solids and liquids are not compressible when they are in a condensed state. Okay, they are not compressible at all. Okay, and gas and liquids, I've told you that gas and liquids are the fluids and they can flow, and this is the nature of the matter. Gas and liquids flows and they are known as fluids, and solids and liquids are in a condensed state and they are non-compressible. Okay, remember this chart, very important in 8 paper point of view. States of matter. We know that solid, liquid and gases, these are the 3 different phases of matter. But if you take in detail, there are 5 stages of matter, that is Bose-Einstein condensate, solid, liquid, gas and plasma. So it was arranged based on the temperature wise. So here, if we take temperature like this, lower temperature to higher temperature. If temperature increases, then it goes to plasma. Okay, Bose-Einstein condensate is a very of low temperature, and solids, and they get liquids, it increases. In gases, it increases, and finally in plasma, the total temperature of plasma is very high. That's why these are the 5 states of matter you have to remember. And there is another way of classifying matter that we'll be discussing right now. It's based upon pure substance and mixture. Okay, states of matter. From the above, this translational, rotational and vibrational motion, we can define solids, liquids and gases like this. Solids have definite volume and shape, liquids definite volume but no specific shape, gases definite volume and shape there is not present. Definite volume and shape is not present in gases, whereas in liquids specific shape is absent whereas specific volume is present. In solids both are present. Okay, in solids it is vibrational motion. Vibrational motion. Kya? Vibrational motion. Here vibrational plus rotational. Here only translational motion. Okay, in vibrational motion, due to their less compressibility, they are not compressible. Due to their less compressibility nature, the molecules are tightly packed and attractive forces are more. Thermal motion is less. What is thermal motion? Kinetic energy. In translational motion, attractive forces are less and thermal motion is very high because they get separated. In gases it is loosely packed molecules. This is what you have to remember. And I've told you that there is classification of matter in a different type other than the Bose-Einstein condensation to plasma. So here what it is: pure substance and mixture. What is pure substance? Pure substance that is available in any form. It's a pure substance which is available in original form from the earth crust. And this is element and compound. Two kinds of pure substances are present in our earth. There are element and compound. What is the difference between element and compound? Element is nothing but only like elements, only like. For example, oxygen is a separate element, carbon is a separate element, N is a separate element. What about the compound? Compound is generally associated with two or more atoms. For example, CO2, H2O, these are known as compounds, and you might call it as molecule. For example, H2O, it's a molecule, right? But it's a form of a compound. Compound, there is another type called organic and inorganic compounds. Inorganic compounds. Inorganic compounds are generally known as molecules. Organic compounds are generally known as molecules. This is what you have to remember. Okay, and there is also a certain very important terminology here, that is phase. What is phase? Or in a general conversation, you might have learned, you might have heard this word called phase. Some might have told you it's very bad phase is going on in my life, or if you are happy then you say my life is going on pretty well. It's a very beautiful phase of my life. It is very bad phase of my life. It's a very worst part of my life. It's a, like, we say like that. It's the phase. What does a phase mean? Phase is nothing but the constituent part of a system. Constituent part of a system. This is known as phase. In general, it is known as uniformity, constants, maintenance of constancy. Okay, that is known as phase. Phase is nothing but uniformity. Okay, when a substance changes from solid phase to liquid phase, then it's known as melting. Liquid phase to gas phase, it is known as evaporation. Gas to liquid, condensation. Liquid to solid, then it is known as what we call freezing. Liquid to solid is known as freezing. That's what you have to remember. And it's a phase. And in phase, for example, if you take a beaker and pour some water in it, and if you pour benzene in it, both are colorless, and they are colorless and they possess similar kind of physical nature and chemical properties. So that's why they get mixed and they cannot be identified as a separate, but they get separated by a thin layer like structure, and the bottom one is called water, we have told, and the upper one is benzene. here benzene is an organic phase. Benzene is an organic phase, whereas water is an it's an aqueous phase. Aqueous phase, organic phase. Okay, that's what you have to remember. For example, if it consider buildings, there are phase 1 block, phase 2 block, phase 3 block. They get separated by a distinct road or a tree, right? For example, phase 1 block, phase 2 block. If you want to differentiate between them, they get separated by a road or any kind of wall or something. Okay, so this is known as there is a separate differentiation between the phase 1 and phase 2. That's what happens in our chemistry also. For example, if I take a beaker consisting of water and benzene, so for example, it gets differentiated by a thin layer like structure. It's clearly visible because due to the formation of different densities, due to the variations in densities, they get separated through a thin layer like structure. It's clearly visible with our naked eyes. And the benzene forms organic phase, whereas water forms inorganic. Water forms what did I tell you? Aqueous phase. And benzene is a non-polar end, and this is known as polar end. This is what you have to remember. Water is polar and benzene is non-polar end. Okay, this is what you have to remember. Don't worry, along with this writings, I'll be providing this entire session PDF in the description box here below, so that you can go there and check it out. Okay, this is what about element and compound. In mixtures, if we come homogeneous and heterogeneous. What's the difference between homogeneous and heterogeneous? Homogeneous means it consists of only single phase. I've told you, one phase. And heterogeneous, it consists of two or more phases, multi-phases or multiple phases. This is what you have to remember. And elements and compounds are homogeneous. You have to remember, elements and compounds are homogeneous, and in mixtures, homogeneous and heterogeneous mixture. Homo, which means same, and it consists of only similar phase. In homogeneous mixture, like compounds together form the homogeneous mixture, whereas heterogeneous mixture, unlike different kinds of molecules and atoms and elements, forms this heterogeneous mixture. Hetero, which means different. Homo, same. Hetero, different. Here only one phase, here two or more multiple phases. This is what you have to remember. Okay, matter in our surroundings. We have told solid, liquid and gas. Let us see the conversion. I've told you solid to liquid is melting, right? Solid to liquid is melting. Liquid to gas is evaporation. Gas to liquid is condensation. Liquid to solid is known as freezing. That's what you have to remember. That's what mentioned here. Liquid to solid, freezing. Solid to gas, sublimation. And gas to liquid, condensation. Like that, you have to remember this entire chart. It's very simple. You might have learned it in your 8th or 9th grade. It's very simple. You have to remember it because basic forms a foundation. And representation of atoms and molecules. Two atoms together form molecules. Two or more atoms forms a molecule. So molecules are the organic compounds. You have to remember it. Molecules are the organic compounds. Molecules are organic compounds. So here if you take H2, H plus H. H is an atom, H is an atom. They two form the hydrogen molecule. O2, oxygen molecule. O is a separate element and O is a separate element, and they two form the molecule N2, Cl2. And coming to NO, NO is a compound, CO2 compound, NO2 compound, H2 is a compound. H2 is what kind of compound? Organic compound, which is nothing but molecules. This is a molecules, right? This is what you have to remember. So depiction of molecules of water and carbon dioxide. Okay, H2O, and this is known as CO2. So this is the structure of water and carbon dioxide. You have to remember. So let's come to atom and molecule. What is atom? Smallest natural particles of matter which is unique and shows all its characteristics. It may or may not have a free existence. This is all. And molecule, smallest constituent particle of matter capable of independent existence under normal conditions. It is independent, whereas atom is dependent. It may or may not have free existence, but molecule has a free existence because they get formed with another element or an atom. For example, carbon chain forms a graphite or diamond. Okay, NaCl, what is table salt, sodium chloride, silicon dioxide. That what you have to know. Covalent network solid compounds do not form a molecule, that is metals. Okay, covalent. What is covalent? Covalent is nothing but, you might have learned this in your 10th grade, that is covalent bonds. Mutual, valent, sharing, mutual sharing of electrons between any two metals. Okay, mutual sharing of electrons between any two metals. And what about ionic? The transfer of electrons from one metal to non-metal, like that. Okay, formula unit. What is this formula unit? Simplest unit which gives the whole number ratio of atoms of different various present in the term as formula unit. It might be a little confusing to you. For example, let us take Al and O. Okay, for example, I've told you this is 1 and this is on the ratio 1:5. So we have to take it in a form of whole number. That's why 3 and 2. So if you do cross Al2O3, this is nothing but formula unit. Formula unit is in the form of ratio. That's why 3:2. This is the ratio, and we have written the form of chemical empirical formula. Okay, chemical formula. It is used for all ionic compounds and network compounds. Formula unit is used for all the ionic compounds and network compounds. Very important in Neet paper point of view. You might be surprised that the same teacher for biology, physics and chemistry. It's because we don't have any faculty. I'm a single individual running this channel. So for that, make sure please support me to make more videos for you. So I'll be more excited if you guys share, because at present we have only 8 subscribers and with 49 views I think for that the biology lecture 1. So for that, please guys make sure share, like, comment, and it gives me some boost up to make more and more videos, because I'm making more and more beneficial content for all the medical students out there and for all the science students. But I need some attention from you guys. Please share with your friends, because it makes me boost my mind and to make more and more videos for you. Okay, because I'm the single individual running this channel, recording, editing and all kind of stuff. So for that, please guys, please support me. Okay, do you want to collab with me? And I'll be taking a demo of you before going to collaboration. So for that, please mail me to my Gmail account, that is smartbookcommunity@gmail.com. I'll be leaving that email ID in the description box even below, so that you can go to that you can go to Gmail app or any that website and mail me, so that we can discuss about our collaboration and we'll take a demo and then we can proceed with, and we'll be it will form a big community for all our students out there. Okay, so for that, please guys, please make sure share it with your friends. Okay, so let's get started. Okay, structure for NaCl. For example, you see a picture over here, that is NaCl structure. This is the NaCl structure. Okay, so for example, consider violet one as Na and green as Cl. Okay, so first of all, we need to know the formula unit for NaCl. It is in the ratio of 1:1. How are we gonna decide that? So write the electron configuration for Na: 1s2, 2s2, 2p6, and forms 10 and 3s1. Okay, 1 valence electron, and here seven valence electrons, and the valency is 1 here and the valence is 1 here. What's the difference between valency and valence electrons? These are the very basic concepts. You might have learned it in your 10th, but again I'm repeating, what is the difference between valency and valence electrons? So the outermost shell, the number of electrons that is present in outside of the shell is known as valence electrons. Here the valence electrons are 7 in chlorine, and in Na the valence electrons are 1. So what is valence? The combining capacity of an element. What is the number of atoms that required to get stability? Okay, to get stability required, it may be losing or gaining. Here Na can lose 1 electron. Okay, here the valency becomes 1. Okay, plus 1, because it's gonna lose 1 electron, that's why plus 1. If it's gonna gain 1 electron, then minus 1. It depends on the number of electrons it would like to give or accept. Okay, in chlorine it requires 1 electron, that's why it's minus 1. Okay, did you get the point? So Na loses 1 electron, Cl gains 1 electron. So if we write like this, Na plus and Cl minus, so here is 1:1 and it forms NaCl, table salt compound. This is how we get the NaCl. And here is silicate, quartz. Here is the structure of silicate, that is nothing but quartz. It's a network solid. A network solid. What is a network solid? It forms a group of network-like structures, a rib cage-like structure. Cage-like structures forms a network, and these networks forms a network solid. And for example, for this network solid is silicate. What did I say? Cage-like structures. These are the cage-like structures. These are the cages, right? Cage-like structures forms a network. Network forms a network solid. Network solid forms this silicate or quartz. Okay, this is a structure. That's one very important. And diamond, here is a diamond for you. Diamond is made up of several carbon units, and these carbon units form the diamond. It's a very hardest substance on our earth. Okay, this is known as diamond. It has very shining property and has high refractive index. So here is graphite. So here we can see graphite structure. It consists of total like hexagonal 1 2 3 4 5 6. So that's why they are known as hexagonal rings. Hexagonal rings forms the network. Network forms the network solid, hence it is also known as network solids. Any cage-like structure or any hexagonal ring-like structures forms a network. If it's a solid, then it's known as network solid. And finally they are known as graphite. Okay, and here let us see some of the important parts in the graphite structure. What are they? So in graphite, the covalent bonds, you have to remember it, and carbon atoms and van der Waals forces. What are van der Waals forces? The forces that are generated by induced electrical units. Induced electrical units. The force that is generated by induced current or induced electric current units is known as van der Waals forces. Due to this van der Waals forces, graphite, there is also another form of graphite, that is graphene. Graphene is 200x times stronger than steel and lighter than 6 times lighter than copper. So graphene is a good conductor of heat and electricity. That's why due to the presence of van der Waals forces, it is used, and as well as graphite is used as a lead in pencils. Okay, do you get the point? And physical and chemical properties. What are these physical and chemical properties? Physical properties can be measured or observed without changing the identity or the comparison of the substance. Okay, this is what you have to remember. Physical properties can be measured or observed without changing the identity. physical, if you want to calculate the physical property of a substance, it doesn't require to change the chemical composition of a substance. Whereas if you want to check the chemical property of a substance, so it may take, so if you want to perform a chemical reaction or substance, it may become another one, right? So let us take to the second point. The measurement or observation of chemical properties require chemical change to occur. If you want to observe chemical properties of any substance, chemical change should occur. With the chemical change, it may not retain as same as the old one. For example, if you take any ice cube, right? Ice cubes, it's in the form of solid. If you perform any chemical operation on it, for example, if you try to heat it, it's gonna turn into liquid, that is water. So it is not gonna be as before. You have to perform some chemical reactions. So that's why chemical properties, if you want to check the chemical properties, you need to do some chemical reactions on it. Whereas for physical properties, it doesn't require any actions on it, but by looking at it and touching at it, we can define it. Okay. Measurement of physical properties does not require the occurrence of any chemical change. That's what I've told you right now. Why it's not writing? Oh, yeah. So yeah. Okay. Measurement of physical quantities. So how did we measure the physical quantities? In units and dimensions chapter, that is physics chapter 1, units and dimensions, we have learned about, in lecture 1 we have learned about what is physical quantity. Physical quantity is a quantity that can be measured by an instrument, and we have come to know about several kinds of physical quantities and some supplementary quantity units and all. So make sure go through the link in the info cards or in the description given below, so that you can have a brief look at it. So how do you measure the physical properties of a substance? Quantitative measurement of properties is required for scientific investigation. Many properties of matter such as length, area, volume, etc. are quantitative in nature. Earlier, two different systems of measurement, English system and metric system, very important. English system and the metric system are the two important systems that is used for measurement in chemistry. International system of units, there is a table over here, I didn't mention it. So if you remember that table, make sure write it down in the comment box or mail me. So we have learned amount of substance. What is the unit for amount of substance? Mole. What is the unit for current? Ampere. What is the unit for length? Meter. What is the unit for mass? Kilogram. What is the unit for luminous intensity? Candela. So there are several kind of stuff I've told you in units and dimensions lecture 1. If anyone didn't watch it, tap the info cards to get a detailed knowledge about it. So with this, we end our precious session. So we're gonna wind up this session. So I've tried my best to teach you and understand you well. If you didn't understand, so make sure before going to sleep, again listen this lecture at a speed of 2x or 1.5x speed. In YouTube there is a setting that is you can set the playback speed to normal or 1 or 2x speed, so that you can have a quick revision app. Okay, so you have to subscribe to SmartBook and make sure like, share, comment, and don't forget to share it with friends, and comment down or mail us for any queries. Okay guys, I hope you like this video. Thank you and bye bye.